In this lecture, we will learn about data, types of data, and the relationship of data with statistics. Let's start with data. What is data? Data is a fundamental concept in statistics and data science. It refers to raw facts, figures, observations, or measurements collected for analysis, interpretation, and decision making. So basically, data is a collection of different things like numbers, words, symbols, or images which say something. And the information that they contain is termed as data. They have some characteristics, some sort of behaviors that should be studied in order to get some conclusion with the help of analysis and interpretation. Data is typically collected during experiments, surveys, observations, or transactions. Whenever we are in some sort of problem or we want to reach a conclusion, we need some factual information. At that time, we collect these informations which we term data. And for example, when students complete an exam, their scores become data. Another example, when in marketing, the pupil or customer respond to a customer satisfaction survey, then their opinion are converted into data. Their opinion is termed as data for researcher. Data around us like weather update, social media usage, online shopping patterns, and even traffic sensors all generate continuous stream of data. In statistics, there are two primary types of data: qualitative data and quantitative data. Qualitative data describes quality or categories, example, color, gender, or nationality of an individual. While quantitative data deals with numerical values that can be counted or measured. For example, height of a person, income, or temperature. Depending on the context, data can be discrete in nature, that means specific or countable values, or continuous in nature, that means the values which lies in a range. So discrete and continuous data is a sort of classification of data, whereas qualitative and quantitative part is the basic types of data. The data exists in real society in around us or in businesses. This has been classified under qualitative data or quantitative data. And this qualitative or quantitative data can be of discrete form or can be of continuous form. Some example of data includes test score of a student, which is a quantitative form of data, name of a country, that is India, Australia, America. These are the example of qualitative data. Daily temperature readings, 5 degrees Celsius, 8 degrees Celsius, 23 degrees Celsius, such sort of information is termed as quantitative data. While customer satisfaction rating, when we are doing survey where we are getting the rating or customer satisfaction information, this data can be qualitative in form or can be quantitative in form. So, understanding what data is and how to collect it properly is the first and most essential step in any statistical analysis. Without data, no meaningful insight or conclusion can be drawn. Now, let's start to understand what are the importance of data. Data play a vital role in today's information-driven world. It serves as a foundation of statistics and is essential for informed decision making across nearly every field, whether in science, business, healthcare, education, or technology. Data provide a raw material needed to gain insight, recognize patterns, and support logical reasoning. One of the most important use of data is to draw conclusions and make predictions. For example, business analyze sales data to identify customer preferences and forecast future demand. While government use census data to plan public services and allocate a resource efficiently. In healthcare, patient data helps to detect disease patterns, evaluate treatment effectiveness, and guide policy decisions. So these are the some example which shows that data are used to draw conclusion and make predictions. Next importance of data is it play a critical role in understanding trends, relationships, and patterns. With the help of data, we try to find the relationship between two or more things. By organizing and analyzing data over time, researchers and professionals can uncover insight that might not be obvious at first glance. For example, data analysis can reveal trend in climatic change, educational performance, or market behavior. Next importance of data is essential for problem solving. Data enables evidence-based decision rather than relying on guesswork or assumption. We take decisions with the help of data on the basis of realistic fact. In a competitive environment, organizations that leverage data effectively often gain a significant advantage. In this age of big data and artificial intelligence, the importance of high quality, reliable data has grown even more. The value of any statistical conclusion or model heavily depend on data used to build it. So we can say that data is not just a number or fact. It's a key to understanding, decision making, and progress in modern work. Without it, meaningful analysis would not be possible. Now, we will try to understand the types of data that we have discussed during introduction section in detail. In statistics, understanding the types of data is crucial because it becomes the kind of analysis that can be performed, the tools that can be used, and how results should be interpreted. Broadly, data is classified into two main categories: qualitative data, which is also termed as categorical data, and quantitative data, which is also termed as numerical data. Each of these data has its own subtypes and serve different purpose in statistical analysis. So let's start with qualitative data, that is categorical data. Qualitative data refers to non-numerical information that represent attributes, categories, or labels. This type of data is used to describe characteristics or qualities that cannot be measured in number, but can be grouped or categorized. Although it doesn't involve numerical values, qualitative data can still be analyzed using statistical tools like frequency tables, pie charts, and modes. Let's discuss some subtypes of qualitative data. First, nominal data. Nominal data consists of categories that do not have natural order or a ranking. Each category is distinct and no mathematical operation can be performed on them. For example, gender. Gender can be either male, female, or other. Instead of these genders, there is no gender is existing on Earth. Same way, for representing the color of eyes, we can say blue, green, brown. Such sort of data has their specific name, and these names cannot be replaced with the help of any sort of numbers. They have their uniqueness. They are nouns. They are adjectives that cannot be represented in numerical or any sort of analytical form. They have their own names and they will be represented in a real world with their name only. These were the example of nominal data. Now we come to the ordinal data. Ordinal data are also a type of qualitative data. Ordinal data, we can categorize or we can quantify or can run basic statistical tests. Ordinal data is quite more efficient than the nominal data. So let's come to understand the ordinal data. Ordinal data include categories. For example, education level. We can categorize the level of education like high school, intermediate, bachelor's, master's, PhD. In this way, we know the order of education, that is, which is a lower one and which is a higher one. But if we say, what is the difference between intermediate and high school? What is the difference between bachelor's and intermediate? Then exact difference cannot be illustrated or expressed. We just say it is lower order, it is greater than the first, it is greater than second, it is greater than third. In this way, we can say, we can express ordinal data. And next sort of ordinal data can be a ranking in a competition. In a competition, one person come on first rank, another is coming on second rank, then another is coming third rank. Then on the basis of performance, on the basis of any sort of judgment that judges have done, this first, second, third has been categorized. But exactly what was the difference between first and second in quantifiable term, we cannot see. It was subjectivity of the judges. They think on some measurable aspects. This candidate should go on first, this should go on second, this should go on third. Though ordinal data reflect an order, but one cannot quantify the difference between ranks. That is why we can say these data are ordinal data. So nominal data, ordinal data, these are the two sort of qualitative data. These data cannot be represented in terms of numbers, but they have some specific identity. On the basis of that, we identify that it is coming in the nominal data category or it is coming in the ordinal data category. Now, go ahead to the quantitative data, that is numerical data. Quantitative data refers to the information that can be measured or counted. It is expressed in numbers and allow for a wide range of statistical operations such as mean, median, standard deviation, and regression analysis. The test or the analysis that we have termed here, that is mean, median, standard deviation, and regression analysis, these all analysis or these all statistical operation can be performed only when we have information in terms of numbers of. These information cannot be applied during the qualitative aspect. Qualitative aspect, a qualitative data can only expressed, can only eligible for the statistical operations like frequency distribution, like represent data in the form of pie chart, represent data in the form of orders, increasing to decreasing order, that is descending order or ascending order. Only such sort of analysis can be done on the qualitative data. But quantitative data has eligibility to come with more specific statistical operations like mean, median, mode, standard deviation, regression analysis, correlation analysis. Such sort of tests can be applied on the quantitative data. Now, we come ahead to understand quantitative data more deeper with the help of subtypes of quantitative data. So, quantitative data can be discrete in nature or continuous in nature. Discrete data represent values that are countable and cannot be broken down further into smaller units. There are two things that I have said here. Things that should be countable in nature, that means can be expressed in the form of numbers and specific numbers. And the numbers should be that specific that this number cannot be break further in more smaller units. So discrete data is a representation with the help of a specific number. These values are often whole numbers. For example, number of students in a classroom, and you can say that 50, 60, 100, 150. In such sort of numerical specification, you can represent the number of students in the class. Another example, number of books present in a library. This can be also expressed as the discrete data. So discrete data is ideal for counting objects or occurrences and is used in the situation where only specific values are possible. Now come to the coordinates data. Coordinates data include values that are measurable and can take any value within a given range. A range should be specified that this is a range. In this range, these sort of pupils lies. So if you want such sort of people, they will be here. So that ranged data is expressed with the help of coordinates data. And this data is also the data which can be represented in the form of numbers, so that we can say coordinates data are measurable in nature. Now, unlike the discrete data, coordinates data can be divided into final labels. Coordinates data is ideal when precision is required, and the variables can theoretically assume infinite value within a specific range. So, this was about quantitative and qualitative data. That is, these are the two major types of data. Understanding the types of data is a foundational step in statistics. Qualitative data help to classify information into groups or categories, while quantitative data allow for precise measurement and detailed numerical analysis. Recognizing whether data is nominal, ordinal, discrete, or continuous. On the basis of this recognition, researchers and analysts apply the correct statistical method, ensuring accurate and meaningful conclusion. Now, next question arises. We are discussing about data. We are going to get with data. We are saying data is a basic entity of a statistics. Now, question arises, from where we get this data? What are the sources of data? So, in order to answer this question, we can come at one conclusion that there are two basic sources of data. First, primary source of data, that is primary data. Second, secondary data. In statistical research and data analysis, understanding the source of data is essential. Data can be generally classified into primary data and secondary data based on how it is being collected. This classification helps researchers choose appropriate data collection method, understanding reliability of data, and assess its relevance to the problem being studied. So let's start to understand the primary data in detail. Primary data is the data that is collected first-hand by the researcher for a specific purpose of the study. It is original and collected directly from the source, typically through surveys, interviews, observations, or experiments. Primary data are original in nature because it is being collected first time by the researcher. And the information collected in primary data is specific in nature because we have started collect this data by analyzing the research objectives. We reach to the target audience and we collect that data from the origin at the real situation. Next, primary data is up-to-date data. It is a current and relevant data that helps to reach at a conclusion at real time. Next, primary data is considered as more accurate data because it is in control of researchers. Hence, researcher has their logical entities to understand during collecting data कि what sort of information is necessary for research or what sort of information should be ignored. Or for collecting these primary data, we use the specific methods that are survey and questionnaire. During survey and questionnaire, we basically takes the opinion or feedback from the target groups with the help of a set of questionnaire. Next sort of method to collect the primary data are interviews. During interviews, researchers do one-on-one or group interaction with expert or the pupil which are related to the research objective to get the detailed insight from them. Next is observations. Observations is basically best and maximum used method to collect the primary data. Observation is about the watching the behavior or situation in natural or controlled setting. Next is experiment. It is a method of data collection under the scientific procedures, under the simulated conditions. It has been conducted under controlled situations to test some hypothesis or some situations. So experiment basically went with laboratory or simulated environment. In these environment, a researcher or scientist test a specific behavior which is termed as hypothesis. For example, a market researcher conducting a consumer survey to study the product satisfaction. It can be collected with the help of survey or questionnaire easily. While the example for experimental research is a scientist performing an experiment to measure the effect of a drug in laboratory conditions. Next, a teacher using questionnaire to assess the student feedback. This is also a method of collecting the data from the target audience. These all data are a sort of primary data. Now, let's go ahead understand secondary data. Secondary data is the data that has already been collected, compiled, and published by others. And a researcher reuse that data for their analysis or references. It is typically sourced from books, journals, government reports, organizational records, and online databases. Secondary data is basically pre-existing data. It is already available from other sources. Using secondary data instead of primary data is time-saving because its availability is quicker and cheaper to obtain than primary data. And secondary data gives a broad coverage. Secondary data often includes large-scale or historical data sets. And these secondary data can be collected with the help of government publications, books or journals, research papers or dissertations, websites and databases. Some examples of secondary data are using World Bank data to study global economic trends. If we are using World Bank data in order to understand the global economic trends, then the data that is collected from the World Bank database with the help of websites, journals, or publications, then this sort of data is termed as secondary data. Referring to historical weather data from the meteorological department, this is also a sort of secondary data. If we want to know about what were the better weather condition 1 year before, 2 years before, 100 years before at that particular city from the meteorological department, then this data is also termed as secondary data. So these are the basic source of data. First was primary source and second was secondary source. These both sources, that is primary data and secondary data, play a crucial role in statistical research. Primary data provides more accuracy and relevant information, while Secondary data offer convenience and broad access to information. Researchers often use a combination of both, depending on their goal, resources, and time constraints. Choosing the appropriate types of data is essential to ensure valid conclusion and meaningful insight in the study. Now, in this section, we will try to understand the relationship between data and statistics. Why data is important in statistics? In statistics, why everything is roving around data. The relationship between data and statistics is fundamental to understand how information is processed and utilized in the real world. Data represent raw, unorganized facts and figures collected through observations, measurements, or research. It can come in various forms: numbers, words, measurements, or even images, and on its own, it may provide much insight. While statistics, on other hand, is the science of collecting, organizing, analyzing, interpreting, and presenting data, uncover patterns, relationships, and trends. In simple words, data is the input, while statistics is the process that transforms this input into meaningful information. The process being with data collection, the foundation of any statistical analysis. The foundation of this statistical analysis begin with data collection. Once data is collected, data is organized into categories, tables, or spreadsheets to bring structure and clarity. Next, this data is summarized using the descriptive statistical tools such as graph, chart, averages, medians, or standard deviations. It makes data easier to understand and interpretation. After summarization, data is subjected to statistical analysis, where inferential techniques are applied to make sense of it, to identify trend, to test hypotheses, or to predict future outcomes. This is where statistics reveal insight that were not obvious in raw data. In conclusion, data and statistics are intrinsically connected. Without data, statistics has nothing to analyze. Or without statistics, data remains meaningless. So we can say that together they form a backbone of informed decision making in the field of science, business, healthcare, and social sciences. Simply, we can say that statistics gives life to data by turning it into actionable knowledge. Now, we will try to understand this connection between data and statistics with the help of some real life examples. First, we will come to the use of data and statistics in decision making field. Let's take a scenario. A retail company collects sales data from all its branches nationwide, including their product name, prices, quantity sold, and customer feedback. Now, here how data and statistics will apply. Let's come to that point. Company use descriptive statistics to summarize total sale and identify the most and least popular product. It use inferential statistics to predict future trends and customer preferences based on seasonal buying patterns. For example, they may find product A consistently selling well in winters instead of product B. Then they decide to increase inventory before winter season to manufacture product A. So, what is the outcome from it? They can do a better inventory management, target marketing, and maximize profit by focusing on high performing products. Statistics and data help this company to get to this particular decision. Next, we will take example from the education and student performance. In education field, A school maintains a database of their student exam scores over academic year. Now, how statistics apply here? Teachers use mean, median, and standard deviation to determine the class average and distribution of scores. Statistical charts and graphs helps to visualize student performance and comparative analysis to identify higher achievers and students who need additional support in their studies. So with the help of this data and statistics, the school can decide that they should need to use customized teaching strategies in order to improve students' outcome based on the performance trends. This is the example for the relationship between data and statistics in the education field. Now, we will jump toward the healthcare and public health field. How data and statistics helps in this field. Hospitals collect patient data such as symptoms, treatment effectiveness, and recovery time. This data comes to interaction with statistics with the help of medical researchers. Medical researchers use statistical analysis to evaluate which treatment work best for the specific condition. They also track disease pattern to detect outbreak and inform public health policies. What do it helps? It helps to enhance treatment protocols, to get early detection of health risks and more effective healthcare strategies. In this way, data and statistics helps in healthcare and public health field. Next, data and statistics is highly used for the sports analytics. In sports, coaches collect players' performance data like number of passes, goals, and speeds. This data helps coaches to understand the performance metrics. They evaluate player efficiency, design training programs, and decide team formations. So it helps a team improve their performance and make strategic game plans. Next, in social media and marketing, social media platform gathers user engagement data like shares, views, and time spent. And this data used by marketers to identify audience behavior, test ad effectiveness, and optimize content using A/B testing and trend analysis. It helps companies or social media platforms to understand the higher engagement, better content strategy, and increased conversion rate. So, these above 5 examples helped us to understand that data is a raw input and statistics is a process that transforms into the actionable insight, guiding smart decisions in everyday life scenario. So, at last, we conclude this particular session with the phrase that data is a backbone of statistics. Without data, statistics cannot exist, and without statistics, data remains meaningless.